Discussion is an application of dimensional analysis. It's a very common question for 2 or 3 marks if this chapter is tested for the exams. A large fluid star oscillates in shape under the influence of its own gravitational field. Using dimensional analysis, find expression for the time period of oscillation. Capital T in terms of radius of the star R, mean density of the fluid rho, and universal gravitational constant. The first line is not important for us. Gravitational analysis, what we need to know is only which quantity depends on what all other quantities. So they're asking expression for the time period of oscillation in terms of R, rho, and capital G. That means time period has to have a dependence on radius, density, and capital G, acceleration due to gravity. So the first step is identifying which quantity is given depending upon which quantities. Here it's clear, expression for T is asked in terms of R, rho, and capital G. So T depends upon R, rho, and G. The question only say depends on, it don't say what power it depends on. So our aim is to find the power of radius, density, and universal gravitational constant deciding T. So the first step is we're writing T depends means proportional to radius, density, and G. Since powers we don't know, we are just putting A, B, C as variables. And last, our aim is to find these powers A, B, C and substitute back in the equation. Always when we change proportionality, it will be a K. So T equal to K into the rest part remains same. A, B, C for powers for radius, density, and G. This K is a dimensionless constant. This K is like a number 2 or 3 without any dimensions. Now, before moving to the next part of the question, the dimensional analysis demand dimensions of time, radius, density, and universal constant of gravitation. This is to be learned from the table, what we discussed, or you need to make a table of all the basic quantities and few fundamental quantities and their dimensional formula. So we substitute for T, time is T raised to 1, radius is length, so L raised to 1. Now density is mass by volume. Mass is m raised to 1, volume is L raised to 3, so m by L raised to 3. M raised to 1, L raised to minus 3. Capital G you can find from F equal to force equal to capital G into mass 1 mass 2 by d square. So from that G will be equal to F d square m1 m2. When you substitute and solve, you get m raised to 1, L raised to, this for density, substitute you get m raised to minus 1, L raised to 3, and T raised to minus 2. So all the quantities involved which are having dimensions, we need to know the dimensional formula. After getting, the next step is substitute LHS and RHS with dimensions. So T becomes T raised to 1. K will go because no dimensions. R raised to A become L raised to 1 raised to A. Rho raised to B becomes M raised to 1, L raised to minus 3 raised to B. G raised to C becomes M raised to minus 1, L raised to 3, T raised to minus 2 raised to C. So this is instead of time, L raised to 1 is a dimension of R, exponent A is here. Rho is M raised to 1, L raised to minus 3, exponent B is here. G is dimensional formula, M raised to minus 1, L raised to 3, T raised to minus 2. The C is outside. Now, open the bracket. So L raised to 1 into A will be L raised to A. B will come inside. M raised to B, L raised to minus 3B. C also will come inside. M raised to minus C, L raised to 3C, T raised to minus 2C. A, Bn minus 3B, minus C, 3C, minus 2C. Now we have L's many here. M also there are two terms, T only one. So group all this into 1M, 1L, and 1T. So if they're common base, we can add the exponents. And it's better keep the order always M first, L next, T. So M, L, T that order. Even left hand side only T raised to 1. We can just put M raised to 0, L raised to 0 because it's not present. So M raised to 0, L raised to 0, T raised to 1. M will be, there's a B here, there's a minus C here. So common base adding exponent B minus C. Into L raised to A is here, L raised to minus 3B is here, L raised to 3C is here. So L raised to A minus 3B plus 3C. So L all over, M all over, now T raised to minus 2C. So left and right are just M, L, T. Now you can equate common base exponents. So M raised to 0, M raised to B minus C. So B minus C is supposed to be 0. L raised to 0, L raised to A minus B, A minus 3B plus 3C. So A minus 3B plus 3C has to be equal to 0. Then T raised to 1, T raised to minus 2C. So minus 2C has to be equal to 1. So better we equate the last one. We get solve C from that. So T raised to minus 2C, T raised to 1. So minus 2 is equal to 1. From that, C equal to minus 1 by 2. Minus 2C equal to 1. Minus 2 will come down. So C equal to minus 1 by 2. Got C. Now, instead of taking 3 terms, always take only 1 term. You get directly solved. Then take 2. Then take 3. So B minus C will be 0. If B minus C is 0, that means B equal to C. We already got C as minus 1 by 2. So B and C both equal to minus 1 by 2. So A, except A, we got B and C. Now for finding A, equate L. So A minus 3B plus 3C equal to 0. So you know B and C, so take B and C to the right side. A equal to 3C plus 3C minus and 3B plus. So 3B minus 3C. So 3 times of B minus C. But B and C are equal. So B and C are equal means get cancelled 0. So A equal to 0. B and C are minus half. Now substitute the values of A, B, C in equation 1. So it will be T equal to K into R to the power of A is 0. B and C are raised to minus 1 by 2. Any quantity raised to 0 is 1. That will disappear. 1. Then all negative exponents we can make positive by putting in the denominator. So rho raised to minus 1 by 2 equal to 1 by rho raised to 1 by 2. G raised to minus 1 by 2 will be equal to 1 divided by G raised to 1 by 2. Now every time raised to 1 by 2 can be taken as a root. So rho raised to 1 by 2 is root of rho. G raised to 1 by 2 is root of G. Since both are in root, root of rho into G in the denominator. That's a final expression. So every question, the common format we follow. From question, identify what all factors given depending upon a particular physical quantity. Then use those all quantities with symbols and put unknown exponents as A, B, C, X, Y, Z like that. Then change into equal to sign. So there will be a dimensional constant. The rest remains the same. And next part is we need to know the dimensions of all the quantities on the LHS and RHS. So list the dimensions of all the quantities on the LHS and RHS. After that, in place of each quantity, substitute the dimensions. So T will go as T raised to 1 dimension formula. K don't have a dimension. R will come as L raised to 1. Rho will come as M raised to 1, L raised to minus 3. The exponent A, B, C remains the same, similar to that. Then open the bracket to get A, B, C into the bracket, inside the bracket, then make all M together 1, adding exponents, L together 1, T together 1, and try to solve with the least number of exponents. So solve the equations, you get the final formula, substitute in the equation number 1. Every exponent negative, try to make it positive by changing, if it's in denominator, to numerator, or numerator back to denominator. We only did numerator, so if it's negative, come to denominator. If it's raised to 1 by 2, that you can change as root. The rest you can just leave as it is.